Hello, everyone. Thank you for being here. Please don't sleep after lunch. I'll try to do the same. So welcome to Your Dreaming. Thanks to all the sponsors that make this event possible. So we are here today to talk about Lightning Web Security and Locker service, Lightning Locker now. So just one thing before starting is that when I applied to this session, it was supposed to be a 30-minute talk. So now I have 50 minutes. So depending on how it goes, I have a second presentation that I might present or not, depending on the length, question, etc. But we'll get busy, don't worry. So who am I? So my name is Fabien Taillon. I'm a 7-time Salesforce MVP. I'm from France, as I guess you can hear. I'm a CTO at Texai, which is a French consulting company. I'm also the developer group leader in Paris, part of a French Touch Dreaming, which is the same type of event, but in Paris. So I'm in the team, and this year is in December 1st. If you want to visit Paris, you can come. Tickets are already on sale. I speak to a lot of events, and I try to blog, but I'm not that good. So only a few blogs per year, but there is my Twitter account here. If you want to follow me or ask questions after the event, you can feel free to reach out to me and our blog at Texai. So, okay. So first, before talking about Lightning Locker and Lightning Web Security, I will just remind you why this does even exist, actually. Why do we need this kind of security architecture? So before Lightning, when we were using at Classic time, when we were in Classic on Visualforce, security was done via iframe. So usually what you have is that you have a Salesforce that will be Classic here, works with Lightning too. But every time you have Visualforce, it's a separate iframe with a separate domain name, which prevents access because the domain name is different from several resources, like maybe cookies or stuff like that, access to API. So part of the security was done through this standard feature. Every browser, when you are in an iframe on separate domain, will block a few things. So this was how security was mainly handled. It's a little bit oversimplified, of course, but the idea was there. iframe was giving security to be sure that your custom developments won't impact Salesforce components and frame and everything. But when we move to Lightning, well, it still works the same for Visualforce. It's still an iframe. But when you do Lightning components, whereas it's Aura or Lightning Web Component, they are rendered in the same DOM on the same page as a Salesforce component. So when you see on this awesome mockup, there is one domain, and all components are rendered in the same place, which means that, well, as everything is the same place, everything could potentially access all the same resources. So you can access Salesforce DOM, API, cookies, everything, because you are on the same page as all other components. So would it be Salesforce component, your custom component, any third-party Conga or whatever component you should use from the App Exchange, or even that you download it like on a GitHub repo or something. That the worst thing would be install a package not from the App Exchange with components you don't really know, put them on the page, and maybe there will be some malicious code that will get cookies or stuff like that. So that wouldn't be very secure. So here on this example, I have 3 types of components: Salesforce, mine, and a third-party component. And the issue is that everyone can communicate with each other and maybe store some information. So that wouldn't be very cool, actually. Yeah, that's the best slide of my presentation. So, well then, so how do we solve this problem? So the answer at the time when Lightning came out was Lightning Locker service at the time. And so Lightning Web Security, I'll talk about the differences later about the Lightning Locker and Lightning Web Security, but the goals are the same. So it's really, it's a security architecture to prevent this kind of interaction between components from different namespace. And there are some other stuff like, for instance, you can't, so not only you can't access Salesforce component like DOM or stuff like that, but also it prevents you from calling like a private API from Salesforce. So previously you could without locker. Well, still it wasn't a good thing. Not even talking about security, but it may break at any time. If it's not documented, it can be broken, changed, deprecated at any time. So with local service, not only you can't access other components, but you can't also call like a private API from Salesforce. And on a more technical side, it's like it's enabling some stuff like a strict mode in JavaScript that will help you write better code because it will throw you much more errors than not strict mode. It will enforce CSP, so avoiding you to load content from other websites that may be insecure. So you need to whitelist them first, and access also to a global variable, because of course there are some global variable on the window object that may be accessed from everywhere. And if you change something, even without really wanting to be like malicious, you could break something without even knowing it. So this will give separate scope for all of your namespace. For Salesforce One, you can maybe break your own components, but that will be it. And prototype pollution, which is mainly on this global object, you can add or override some method or variable. This prevents you can't do that on the real global scope of the application. So let's first start by Lightning Locker, and we'll move on to Lightning Web Security after. So how does Lightning Locker works? Well, it's again, it's also oversimplified, but I will give the main idea of how Lightning Locker works. So it makes use of a JavaScript proxy. And the thing is that to prevent you from like breaking stuff on the global object, like window, document, etc., it will not serve you on your components this real object, but like wrapper that will be like secure window, secure document, secure element, etc. And all of these, of course, are documented. We can have a look because we have time, right? And you can see, so there are a lot actually, not only the one I've defined, but several other wrappers are there. So yeah, I will show you quickly how it's working. So it's like a dummy implementation of what Locker is doing, of course, because they have like 15 lines of code, and I think Locker is much more than that. So I have a small app that is here. It's a local app. It's not even on Salesforce, but I will get you the ID. Maybe I should just... Can you read? Yeah, it's fine. Oh, it's, yeah, okay. Can everyone see, yeah, at the top? So here is what so on this side, I have an element which is C. So I've like created elements that look like Salesforce One. It's just on my computer, but it's easier to understand what it's doing. So I have one component which will be C my element, and the second one which is here, that is a Lightning my element. So it's like simulating that you have two namespaces. Of course, if I try in my browser to access these two elements, I can access them because there is no like at the time there is no shadow DOM, no anything. So just regular HTML, so I can access anything. So how could we prevent access to these elements? Like if I do something like okay. If I go to the console, I do something like document dot I can access it, and I can access all the elements with this Lightning namespace, which makes sense because it's just like a regular HTML actually. So how is it possible to avoid that, and how Locker is doing it? So as we don't get the real document, you're getting a secure document, you will go through a proxy object that will check if you have access to the element. If yes, it will return the element, otherwise it will prevent it. So it's what I did actually in a small demo. So I did two buttons here. If I click on my namespace, it will do the exact same line of code I've written there, but with C my element. And when I click on it, yeah, it's a little bit below. I should close that. Let me do it again. Up. So it tells me that I'm trying to get the see my element, namespace is allowed, and I'm able to retrieve the HTML coming with it. If I click on the other one that will try to get the lightning element, it doesn't work. So how is it done? So I'll show you the code, even though it's like, as I said, oversimplified. So here you have the HTML I've showed you with the two elements here and here. When I click on my button, I'm calling a method that is getting the two HTML elements name. And here is the function. So when I call this function, you see I sort of override the standard document variable, let's say, with a new proxy. So proxy, like this specific standard JavaScript element. And I will say, okay, for Windows.document, so it's the element that I want to override, use instead secure document. So every time we will try to use this, sort of use this proxy instead. And then just below, so I'm writing the same line of code you've seen below. I'm not writing like secure document or my document or whatever .getElements by tag name. I'm really calling like document. And what it does, it will go through my secure document that I defined just upstairs. And here, what I say is, okay, this is the definition of my proxy. It's, okay, if I enter this proxy at this time, and that the property that is trying to get access is getElements by tag name, do something. And well, I guess the real code is a little bit more complicated than that, but the idea is like, okay, I'm trying to get access getElements by tag name. Is the namespace C? Yeah, okay, so return it. Is it something else? So no, you can't access it. So that's basically how local service is working. Again, much more oversimplified than the reality, but the idea is this. It's everything you will access, all these global elements, secure elements, secure document, etc., will be served through a proxy defined by local service. So you can find the documentation about secure document and everything. I'll show it just after. And all these elements will pass through a proxy that will define if you have access to the HTML, JavaScript API, whatever, etc. So that's the way it's working with local service today. If you have any questions, just feel free to interrupt me. Okay, so the thing is that Lightning Locker works. Okay, so I mean, in terms of, if you just look at security, it does work. So first you saw that it works when you're in the context of your page, which is when I try to write myself in the console of Chrome the command, it returns the element, of course, because it wasn't implemented via my secure element. So if at some point you find a way to get out of Locker, you could access some other stuff. It's not standard stuff. It's an overhead on how all the elements are working. But also, that means that, as you see, I have like created like an if to say if I try to access this element, and then depending on how the element is coded, well, either it could be like I give access to everything, or I prevent access to some other stuff, or the other way around, which will be until we have coded a secure version of this call, you won't have access to it. So there are new stuff like Windows clipboard or barcode detector that may not have been implemented at the time of Locker. And well, until someone in the Salesforce security team code the proxy for this element, you won't have access to it, which is maybe a pain because if you are using any like JavaScript framework, you would have access to it usually. And moreover, this means that any third-party JavaScript framework you want to use that may need access to like global variable or this kind of new method, they just won't work. So we'll try to add a JavaScript library that works everywhere. It won't work in Salesforce just because of that. So well, the good thing is that everything is perfectly documented. So even though it's a little bit painful when something doesn't work because there is not much you can do about it, you can have a look at the documentation. And you can see all these three elements of secure Windows, secure document, etc. And you can see which one is supported, which one isn't. So if you have an error, you can just get there. Or if you want to use, like, I don't know, barcode, I don't know if it's here, if it's a barcode detector. Before trying to use it, you go there, you say, okay, that doesn't work, so you don't need to start working on it. Well, the bad thing is that you can just see it doesn't work and you're just fucked. But at least it's good. It's a good documentation. It's not like we don't know if it's working or not. And well, it's actually much slower, because every time you will try to access one of these elements, so like document.something, instead of just using a regular web API that may be fast and optimized by like a Chrome or whatever, you will go through a custom proxy that will it's just an overhead. So if one standard method is like super fast, you still need to go through Lightning Locker, and every time you access it, it will slow down your application. So depending on how your code is working, is coded, sorry, it will really impact the performance. So there is a good example on the Salesforce documentation I will show you. So another tool is like, so you have two things. It's the same for LWS, as you can see. So you have documentation, so it's local API viewer, local console that you can try code, and you will get sort of the same thing for LWS here. So let's take the example from the documentation. So let's see what it's doing here. It's creating a table, and this table is created by calling document.createElement. So this is the first version. The second one that I will show after is just like sort of creating a giant string and creating it at the end. So what's the difference? The difference is that on this one we are not using document.something, which means we are not using in the loop, we are not calling for each line local service. Whereas on this one, which is doing the exact same thing, and it's perfectly right to code like this, on any other framework that doesn't have local, we are calling, even without knowing it, local service for every line here, so like 5 lines, plus on the whole loop, so a lot of time. So if you try to see the difference, so you can benchmark. So it will test your code and tell you time it takes and time it would take without locker. So you can compare the difference. So you can see that with locker off, so it really depends, because on my print screen it was 10 times. And on Salesforce website it's 6 times. But still, you see here, this exact same code, if I was shutting down local service, it would be 17 times faster. So that's quite a lot. On the other hand, when I go to the other code that is doing the exact same thing, but coded a little bit differently to avoid too many codes to local service, it should be almost identical, maybe one dot something. Surprise. Yeah, 1.06. So even as it's coded completely differently, which makes sense because there is only a few calls to local service in this second example. But you see that for a basic use case, whether you code in one way or another, like the second one is still with Docker, but doing the same thing but coded differently, it's 17 times faster. So you could say, okay, I know it works, I will try to code always this way, but that may not be the best thing to do. Plus, when you try to use an external library, you may not control how it's coded. So at some point, you will have some limitation with Locker. So that was one of the main issues where Locker was slowing down the platform. So you see in my example, it was 10 times, so it's even worse now. And yeah, this is not really a problem anymore, but just I wanted to remind you that proxy, it's something that is there for quite some years now, and you can see the support in all browsers. So of course, it's not supported in Internet Explorer, which means that when you use Internet Explorer, Salesforce created a JavaScript library that does the exact same thing, but custom. So on Internet Explorer, it's even slower, but it's not running proxy, the real one. It's running an implementation. So Internet Explorer is already slow. It's even slower because it's not even running the real stuff. But it's supposed to be retired since like 2 or 3 days ago. 3 days ago. So I guess no one is using Internet Explorer in there, but if you're still, you should stop right now or leave the room. Okay. So now we are moving to Lightning Web Security. So what's the difference with local service? So it's based on something else. It's a new API, standard API from the browser that is called Shadow Realm. So it's much better because it's a web standard. So that means it's not like proxy was standard, but I don't think it was created to have this kind of usage on a whole application. Here, Shadow Realm, the point is really to do this kind of thing. So it was created with this kind of things in mind. So there is a good, actually. So yeah, I'll show you. Well, first, what's the point of a Shadow Realm? It's like you will create a Shadow Realm. You will just write like a new Shadow Realm. I don't have a demo for it, but you just create a new one, and then you can create two Shadow Realms. Could be like one for Lightning, one for your own components, and you can evaluate the code in all of these contexts. So you will create two contexts. So like global variable, like window or this or stuff like that, will be like there will be still the global one. Plus you will create two sub contexts. So every code that will be run can be run inside of these two contexts. And it's not like a workaround like what was this with Locker and proxy. It's really the goal of the thing. So there is same thing. There is a documentation. I can go there. It's almost the same thing, but documentation is a little bit. It's twisted actually. It's not like what's supported and what is not. It's well, from my understanding, you have access to everything, but some methods are what they call distorted, which is you can access anything, but some of them are restricted. So it's not like you have only access to what we coded in the proxy and that you can use because we secure it. It's the opposite. You can access anything, but some of them we know are insecure, so we like twist them a little bit so you can use them without any security issue. So documentation, same, is quite good, and you have almost everything. So it explains actually what was distorted. So I don't know, if you go to a window, you will see the 12. And you will see what can be changed or not. So like for instance, if you try to call fetch, it will say you can't access some URL that are on a private Salesforce API. So everything is it's a very good documentation. So if you want to move to Lightning Web Security, you can just go there and see if you find something not working, you can go there and see if there is distortion on it or not. So why is it good? It's good because first it's much faster because this was created for this very use case, so not something like twisted to make something that was not supposed to be used that way at the beginning. So it's really done for it. On a Salesforce point of view, something that wasn't possible with Locker is that you can use components from several namespaces. So main use case is like I'm an app exchange, an ISV. I want to create a library of components that would be my namespace. So Fabien dash something. You will pay for it, have access to the library. Previously with Locker, if you create some custom component, you can't use my component inside yours, in your code. That was not possible. With LWS, it's possible. So that's one of the big change between the two. So as I said, distortion of API, so you have access to much more APIs than before. And well, it's standard, so that means that when Chrome will like optimize the way Shadow Realm is running, because I don't know, some parts are too slow, well, you will benefit for it because it's just a standard stuff, and everyone will use the standard stuff, and it will be much faster for everyone. And also better support for third-party libraries because, I mean, Salesforce have been leading this kind of new feature, which means that when this was like designed, all these kind of issues that we had with Locker, so like third-party libraries that didn't work because like no access to global variable or stuff like that, the feature was designed with all of this in mind. So now you can use much more higher number of third-party libraries that will work with this because it was designed for this use case actually. So there are a few things you need to be careful of. First, it's only GA for LWC, so not for Aura component. Still, well, so what Salesforce is recommending today is that if you have a new org or LWC only org, you should activate it. actually, Salesforce is like rolling out the auto activation of the feature. I think it was supposed to be on Spring 22. It's not there yet. I don't know. Documentation is like it's rolling out without much more information. So, well, at least if you have an LWC only org, you could activate it. If you have both of them, just test it. Documentation doesn't say don't use it. It says test it correctly. If it works, activate it. But if you have only Aura component, just don't bother. Only have the link with exactly where I took this information. And yeah, there is one thing. So what I did on one project was like, okay, it's a new org. I'm doing LWC only. Perfect. Activate it. And then like, I will never create Aura component. Like, yeah, I can't not create Aura component because I need to put a button on a list view or a related list. I want to override new on edit. I want to use Lightning out or stuff like that. So there are still some part of Lightning experience where you just can't. You have to use Aura component. So you can't just say activate it and I will be fine forever. So I would say what we did so far is that we have already activated it, so it's too late. But we need to test carefully that it's working with a few features you may have to use with Aura. Because that's the thing, actually, that may be a little bit dangerous. So I've been using like the clipboard API that was not working with Aura, with something like to copy-paste. And so let's say, if I had to create an Aura component later on, and that I need to switch back to Lightning Locker, all my code that is supported wouldn't be supported again because I'm going back in the past where all these APIs were not supported. So you need to be really careful about when you activate it. I would say that these use cases are pretty basic because even when I did like, in all of these use cases, I didn't really create an Aura component. I just created a wrapper component that is calling my LWC. So Aura is like an empty shell that will call my LWC. I haven't seen any issues with that, but I don't know. Yeah, maybe you need to have the mic. I don't know. Can we have the mic?
Thank you. When I activate web security, is it applied on managed packages? So it means when I'm a managed package developer and I have my components packaged and you have it installed on a Lightning page and you apply Lightning Web Security, could it break the managed package?
I guess yes.
Yes, it can. So all or nothing. Okay.
So that means, yeah, ISV need to start testing it right now because your customer could use it, yeah. And yeah, the last thing is that today it's not implemented in all browsers. So there is still a polyfill, so some JavaScript custom implementation that is simulating what Shadow Rim is doing. But the thing is that it will come in, I don't know when, but it's something like Locker that will never come anywhere. It was a dead end because it would never be implemented by browser. Now it's a polyfill, but maybe in 1 year it will be implemented anywhere. And you will, for you, that's a good point with Salesforce. You don't really care. You just code like if it was a real Shadow Rim, and maybe in 1 year it will be standard and even faster without you doing nothing. So a few resources. So there was a very good blog post from Salesforce about introducing Shadow Rim. So a team that challenged the creation of this new feature on the I mean not only from Salesforce for Salesforce but for the whole web platform, and a few other stuff like the console I showed you, etc. And one badge that you can do that is quite pretty basic, but it's quite okay. And that's it for this talk. So I don't know if there is any question about this.
I have one question. Do you have any definite or definitive information around the roadmap of LWS? Because I see in the group of the Lightning developers every day, people are posting issues and bugs around LWS. So do you see, is the roadmap promising enough to actually adopt it early? Because otherwise this is just another feature which goes down the drain.
I'm not from Salesforce, so I can't really answer, but for sure I don't see Salesforce going back and saying we abandon it and move back to Locker. So I can't say if it will take like one release or 6 release to get it ready. Maybe that's why they wanted to activate it in spring 22, and now it's like a little bit slower than expected because there are a little bit more bugs than they thought. But I mean, I may be wrong, but I don't see Salesforce saying, okay, it's just too complicated, let's move back to Locker.
Yeah, so I can tell you Locker is going to go away, and Lightning Web Security is definitely here to replace it. It's going to take more time than what we expected. Sorry. Yeah, sorry, repeating. I was saying Locker is definitely going away. This is the past. It was privately developed just for Salesforce, and Lightning Web Security is here to replace it. It will take a couple of releases to really go on because there are a lot of use cases that the developer team hasn't anticipated, a lot of different scenarios, especially around packaging, ISVs, which we didn't foresee. But yeah, that's really the future.
I just want to elaborate on this because if it is an all or nothing option, and so this will be enforced, and you say you have to be careful when you have Aura. I mean, there are so many Aura components and applications out there. Are there specific areas you should take caution about?
I don't know. It's just what documentation says. It's not GA for Aura. So I guess at some point, I don't know if it's at some point we'll get GA. Maybe it will take a year. Or it just today you can use it for if you have any issue with LWC, you can create a case and it will be supported. You have an issue with Aura today. It's not fully GA, so you can't use it. I guess at some point it will be GA for everyone, but I don't know why, if it's 1 year or...
Okay, so that means that Salesforce will implement the same behaviors supporting Aura. So in an ideal world, it should just work because Aura will not go away. And so it's just applied on top, and okay, right now you can't use it, you can only use it as you said. Okay.
Yeah, question is, I don't know when, but...
Yeah, it's really a multi-release effort. And what is really different with Lightning Web Security compared to Locker and the others is that we are also applying it to our own internal components. Salesforce has probably close to 10,000 components, Aura and Lightning Web components that we use internally, and we are applying the same security rules now to our own components. With Locker, we weren't doing this. We're just applying Locker for customer components. So it's going to take some time for sure.
Any other question? So, if not, we have 2 options. We have 15 minutes left. So either you just go and grab a coffee and a cake. I can do my other talk if you're interested. It was Lightning Web Component open source. Don't know if you're interested or not. It's supposed to be 20 minutes, but I can go faster. Okay. Buy one, get one free. Plus, there is some time. I don't have to do this one. So yeah, my title of this one, so welcome to my session. This one was about building your apps everywhere with Lightning Web Components open source. So the idea is you can build application on Salesforce, Lightning Web Component. There is also some stuff that are open source and that you can use somewhere else, like Heroku, AWS, Azure, you name it. So let's see what you can do with it. So I will go a little bit faster, but I don't think we will have time for Q&A, but after you can catch me if you want. So let's skip the agenda. So first, there are several stuff that are open source at Salesforce. So there is a whole website for it, actually. So things you may know, of course, like LWC, extensions for VS Code, SLDS, etc. It was Aura, actually, so what's behind the Lightning experience was already open source at the time, even though it didn't get much more love for the open source part. So there are already lots of things, not the same level of open sourceness, can I say that? So LWC and extensions for VS Code are like really developed on the open source, so you can go to the GitHub repo of LWC, and you can see developers talking to each other, doing pull requests, etc., implementing new stuff. Whereas SLDS is more like what is done with Android. You know, like they are developing stuff internally, and after there is a new release, publish the new version. So it's like you get the latest version of the code that is open source. You just don't see the development process. Other thing is that for LWC or extensions VS Code, or even actually SFDX plugin, as you have access to the code, the real one, you can create your own pull request. So that means, I think I did one for VS Code. You want to add a new feature to the VS Code Salesforce extension, you can just go there, create it, and submit it to Salesforce. And it will be part of a Salesforce official extension, whereas you can do it with SLDS. And there are some other stuff that are not open source, but that are available for you to use outside of Salesforce. So Lightning Web Runtime, which is a runtime for running LWC, or Lightning-based components, so the one you know, like Lightning Button, Lightning Card. You don't really have access to the full source code. Still, you can use a package and use this package outside of Salesforce, like on an open source project, on Heroku, or whatever. That's what we are going to see. So what you can do outside of the platform, it's well using what we just said. So web runtime, components, LDS-based component. Not only, of course, you can create like a wire API if you've done some LWC. So calling an API with a wire will give you a caching mechanism. So that you will call it once, and then if parameters haven't changed for 15 minutes, it will hit the cache and not call the server again. So it will be much faster. You can't create custom one on the platform, but on a Heroku or whatever, you can use it. Navigation service, so when you navigate with your LWC navigation service, that is available also outside of the platform. And there are some stuff, so LightDOM, that is a new feature coming to the platform, was there for a few months, I think, on OSS before going to the platform. Some stuff like dynamic component creation, it's available on Aura, not on LWC, but available on LWC outside of the platform. So you can create component on the fly on your open source project, but not on Salesforce. So it would be like a extended version of LWC, we can say. And then you can use whatever you want. You can use TypeScript or whatever. It's on your own local machine, so you can do whatever you want. So we are going to talk about Lightning Web Runtime. Lightning Web Runtime. So when you try to create a community, so experience now, you have some templates like build your own. Build your own is like an empty template and do whatever you want. And now there is a new template which is called build your own LWR, so Lightning Web Runtime, which is the same as the other one, except it's 100% LWC, which means that even if you create a community with the regular build your own template or all the other you know, like a service or everything, you are still running the Aura runtime. The idea is to get a website that is super fast, like less than a second to launch. And I think like just running and launching the Aura runtime is more than a second. So even if you have super perfectly coded LWC, well, time for Aura to launch, it's already too late to be under a second. So LWR is a new runtime, 0% Aura, 100% LWC. Only issue is that, as you may know, you can't have an Aura component inside an LWC, which means that in this template on the platform, all the standard components from Salesforce that were coded with Aura, so when you create a community, you have like a 30 or 50 components, I don't know, you get almost no one because they are Aura components, so they are not working on this runtime. So release after release, there is more and more, but several are missing. So this runtime actually can be used outside of Salesforce. So you can use the exact same runtime as the one when you create a build your own LWR community. You can use the exact same runtime, but outside of Salesforce, and it will work the same. So so there is documentation right here actually. What you can do is it will give you a basic runtime, and then you can add modules or services to it, depending on your needs, and you can configure almost anything. So yeah, what you need to do is just run npm init LWR. It will ask you a few questions like, do you want to use a static app, single page app, TypeScript, JavaScript, blah blah blah. You just press enter, type a name, and you will get like a basic app that will be running like a hello world application. And then there are a few stuff that you need to do to add additional stuff. So I will go quite quickly because it's on the documentation. If I share my slide, you can go there after. If you want to use SLDS, you need to install the package in addition to LWR. So download the CSS and put it in your asset directory for your app. You need to configure a few things to make it work, to say this is where you need to... I'm going quite quickly, but everything is on the documentation. So you need to create HTML page, and of course reference the CSS, which like any regular web page. A few tricks is that as it's LWC, there is still shadow DOM. That means you need to activate synthetic shadow, which is just a few lines to add to this LWR config.json. It's all documented again, so you can have a look later. But if you want to use it, you need to use it. Otherwise, like CSS won't cascade into your LWC, so you can still have lightning button, but it won't be styled with the correct style. If you add the CSS and add synthetic shadow, it works like on platform. Then same thing for Lightning-based components. So it's not open source, but you can install them via npm. So you create just npm install and set up in the same config file that you want to use this base component. And then if you want to do routing, so like 2 or 3 pages, you have to set up 2 things. So a server-side routing, if I type the URL directly, like myapp.com/mypage, to say where I'm supposed to go. So this is basically, you will set up 1 page and 1 component and a path. So I just put a wildcard, so everything is going there. And then it will use under the C, it will use the component to do the routing. And it will use the routing that is done client-side. And on client-side, this is this part, which is routes on the left. So I will set up like a home page. And then I have a JavaScript handler that will get the name that is passed after the slash. So this is this method. So on the other one, I say, for everything after slash, use this component. And this component is like a giant switch. Like if it's this page, use this component. If it's this page, use this component. And then you can do whatever you want with it. So it's a little bit more work than just setting a community, of course. But once you've done it, it's like 10 minutes to set up something like this. So. And then you have to use like a LWR router container, which you will put your app inside of it. And it will just, every event of navigation will be catched by this component, and it will manage navigation for you with the same way as on platform. So you can use the same component and same JavaScript code. Okay, you need to import create router, okay. So just a word about the custom at wire. So it's very easy to do, actually. So this is a very, very basic use case. I guess there should be a little bit more code, but the idea is you just create an ES6 module. There are a few functions that you need to set up. And basically, this is what I have in my app that I will show you just after. It's I have an endpoint here with an API with a JSON. I will just update it with a fetch and then return the result. And that's it. And I'm using this wire in my code. And it's working like on Salesforce, which is I will call it once. It will do the call. Next time I refresh my page, behind the scene, the caching mechanism of wire service will be there. It will just not call again the service for me. So that, as you see, it's very, very easy to set up. That could be cool to have it on platform, but I guess the idea is to pass through Apex anyway. So, okay, so I have a small demo. So what I did in my demo is basically I wanted to create components that are reusable. Yeah, create one set of components and deploy it both on Heroku and on a community with LWR because it's supposed to be the same runtime. So just to show you if it works. So this is the app that is on Heroku. So it's a free Heroku account, so when it falls asleep, I need to wait for it to wake up. But this is the Heroku app, and this is the one from on the community. So as you can see, it's almost the same thing. Not exactly, because in community you have some theme like a default background, default font size that may override the values from the other. But if I have set up the exact same thing, like a font or everything, it will be exactly the same. And as you can see, so on community, no surprise, it's like a base component, it's navigation, etc. And that's the other one that, of course, is like trying to wake up. Well, I will finish my slide and I will go back with. I should have wake it up earlier. So just to explain differences between OSS and platform, so you can't use exactly 100% the same component. Like, of course, if you call platform-specific import, like static resources or stuff like that, it won't work on Heroku. But it's a few things to change. Instead of importing this, you will just put your asset in your asset folder. Same here. I was using my custom Wire API that I build locally. I can't do it on the platform, so I replace it by an Apex class. Of course, I had to write the Apex class, but it's one line to change it. A few things for navigation. I basically name, my page will be named page, and then I try to deploy it in community, but community say no. This is the name I'm expected. I'm like, oh yeah. So I think if I had done it the other way around, it would have worked, because on Heroku I can use any name I want. And also metadata file that display if the component is available, which is the API version, if it's on a community, Lightning Experience or whatever. It has to be there on Salesforce. If you put it on Heroku, it's just there and it doesn't care, so it's not a problem. So just last slide, I think. It's so you can't reuse 100% of the same code, but if you do like presentational component, like it passes a list of a string, for instance, on display data, it would work. If you have specific import or navigation name specific, you need to think about it before, and maybe you can create a component that will be reusable. But if you create a component and you then say, I may reuse it later, you will have a few things to trick, like change an import, but it's not a lot of work. So these are the resources. I will share the slide. And maybe I can show this if demogos are with me. Otherwise, you won't see it. I should have done it locally, actually, like Philippe said. But I was busy changing the template to the other one. So we can wait a few seconds until someone kick me out of the room. But I don't know if you have any question regarding this. So the idea, what I wanted really to share is that you can have base component, SLDS, and same looking component on Heroku, like for free. You can use Lightning Data Table, you can use everything on Heroku, same thing as on Salesforce. Yeah.
Point from the admin or from the business point, what you see as a use case, not just the playground. What is a business use case where you see this?
To be honest, I think it's more like a geeky thing, but yeah, exactly. Why not? But the thing is also, let's say I'm at my company, I want to build an internal app. We don't know React, we don't know Vue.js, so we have only LWC developers. And if you want to build something that can't be on Salesforce, we could go for it because all our developers already know LWC. So for this kind of use case, it would be useful. Otherwise, I don't see why it should. If you already have developers doing .NET or React or whatever, it should.
I think it could be the use cases for which the age-old use cases like Canvas was being proposed. Like if you already have an application up and running from the past, and you just want to reuse that somehow with Salesforce rather than completely rebuilding it from scratch. Yeah. Canvas used to be one of those options previously.
Like an app that you, can you say again?
Let's say there is an app that you have built already in-house, and you just want to reuse that rather than completely rebuild it again on Salesforce. So some of that, this could be one of those use cases. Let's say if you're lucky, it could be on Heroku, or for that matter, it could be on AWS or wherever. It might be one of those cases where this kind of an approach could be useful.
Yeah, definitely. The other thing after, you can use it on a Heroku, Azure, or whatever. So it's not. It's up to you. You can, if you want, you can take a photo of the URL and go there in 5 minutes when Heroku will wake up, and it basically is the same thing as this. So you will be able to navigate, come back. It's there is nothing groundbreaking to see, just to see that it's the same look and feel, same navigation, and 99% same code. So that's it. Thank you.
Thank you.